So how do we prove the law of cosine? We have a triangle here, and I drew a height, and I called that y, and here I called it x. Okay? I'm going to use the Pythagorean theorem of the first triangle over here. So it will be a squared plus b squared equals to c squared, right? X squared plus y squared equals to b squared. So that's one equation that I can get out of the diagram. What else? It's a law of cosine, so I'm going to go ahead and use the cosine ratio of A. What is cosine of A equal to? It is A over H, right? Adjacent, which is X. H. Hypotenuse is B. Adjacent and hypotenuse, B. So let me go ahead and solve for X, because I'm going to later substitute cosine of A for X. So what do? Multiply by B on both sides. So I get X equals to B times cosine of A. Okay? Now, let me go ahead and look at the other triangle on this side right here. So I'm going to use a Pythagorean theorem again for this. So how do you write an expression of this length right here? Yeah, you see the whole thing is C, and this is what? X. So this is C minus X. Right? So then how do you write a Pythagorean theorem? It is C minus X squared plus Y squared equals to A squared. So we're going to start from there. So C minus X, like A squared, plus B squared equals to A squared. So now we're going to go ahead and take a square of this and try to simplify it in terms of A, B, and Y. So here, let's FOIL this. So this is same thing as C minus X times C minus X, right? When you have an expression square, you don't just distribute it, you FOIL it. You have to expand it and FOIL it. And it's plus Y squared equals to A squared. So now what do you do here? C times C is C squared. C times X is negative CX. Negative X times C is negative CX. So another negative CX makes it 2CX, right? Negative 2CX. And what's negative X times negative X? Positive X squared. And you have Y squared and A squared. So now, is there any way that we can simplify this expression? Meaning, we like to have an expression only in terms of these C, B, and A. So that means we like to get rid of the X and Y's. Do you see anything? Anything you can simplify by using these two expressions? Yes. Yes. X squared plus Y squared was equal to what? B squared. Yes? You see how we can substitute X squared plus Y squared for B squared? And equals to A squared. What about here? What about this X? So it's C squared minus 2C, but again, you're trying to get rid of the X. What is X? What was X equal to? B cosine of A. So this is times C, B cosine of A plus, what do you notice? Isn't this law of cosine? What is law of cosine? A squared equals to, remember law of cosine from geometry? It's C squared plus the other two letters, B squared, and then minus 2 of these two multiplied, CB, and it's a law of cosine, so you have cosine of A. These two are matching. Remember this law of cosine? So here's the end of the proof, and it will work for all the other sides. So if you're starting from b squared, okay? So that's end of proof. But what are the other two law of cosines? So if you have b squared to start with, then the other two term looks like just like Pythagorean theorem. So you already use b. So here's a squared plus what? C squared. And it's always minus 2 times these two multiplied. AC. And it will be cosine of this corresponding letter, corresponding angle to that side, which is B. Go ahead and try to write what C squared would equal to, guys. C squared. I know it's already written on your handout. C squared now will be what? Equal to A squared plus B squared minus 2 times these two multiplied AB. It's law of cosine, so you write cosine of matching. C. So guys, please go over the proofs, okay? You need to know how to prove law of sine and cosine. Okay? Now, if you have time at the end of the class, I'll give you guys time to study and go over this on your own again. But for now, let's go ahead and use the law of cosine to prove the question.